All right, pre-calc group. We're looking at taking graphs. So we're going to be looking at graphs, and we're going to be writing equations. Okay? So, first of all, let's talk about this now. Give me an equation for a graph that has an x-intercept of 3. That's right, it has to have an x-intercept of 3. That's right. All you're going to say is y equals x minus 3. So there we have an x-intercept of 3. Remember, x-intercept is root or 0. Okay? So that's y equals x minus 3. All right, now it has a vertical asymptote. Where do we find the vertical asymptotes? That's right, we find them on the bottom. So that means we're going to have a fraction. Y equals. So, and we got the x minus 3 on top. So we have a vertical asymptote. That's on the bottom. X equals 1. So how do I write that? That's right, we write that as x minus 1. So right now we have an x-intercept of 3. That's at the top. Your intercepts are at the top. And then a vertical asymptote is at the bottom. There we go. All right, now it has a horizontal asymptote of y equals 5. All right? Oh, wait a minute now. What's the horizontal asymptote here? That's right. The degree at the top is the same as the degree at the bottom. So we're just looking at x over x. So right now it's a 1. I need to change it to a 5. Okay, all we have to do is multiply the top by 5. Okay? Right, we cannot do 5x minus 3. Because if I do 5x minus 3, now the x-intercept is no longer 3. The x-intercept becomes 5/3. That's how come I have to use parentheses. We need parentheses, so we can't just say 5x. Okay? Oop, put it in the wrong spot. Y equals 5 parentheses x minus 3 all over x minus 1. Okay? All right. Now, it doesn't exist at x equals 4. So that literally means, remember, that's right, we have to have the same factor at the top and the bottom that will cancel out. So y equals 5 parentheses, I'm going to make this extra long. There's my x minus 1 at the bottom. Okay, and then I have my doesn't exist at 4. So that's right. Oh, let me squeeze this in. And now it doesn't exist at 4 literally means x minus 4 top and bottom. Remember, those cancel out. X cannot be 4. Okay, and then we found the actual y values by plugging in. There, we just wrote the equation out. So based on this information, we see how we can write out the equation. All right, so we have rules. 1, x-intercept. So when I'm looking at an equation, all right, we look for the x-intercept. Where does the x-intercept go? In the fraction. Remember, everything's talking about a fractions. They go at the top. Remember, these are rational equations. So the x-intercepts are at the top. 2, vertical asymptote. Then the next thing we do is take care of the vertical asymptote, because that finishes out the basis of the fraction. That's at the bottom, right. Then we take care of our horizontal asymptote. Okay? And I'm going to put a star next to that, because that star is going to refer to adjustments. I'm going to write stuff down over here. 4, we take care of the y-intercept. Okay? The y-intercept, remember, we've done the y-intercepts when we did the polynomials. So the y-intercept, remember, it's the y-intercept is equal to k times some m over n. All right, so where m and n are constants, when x is not 0, okay? All right, so now, first of all, let's talk about this. So this y-intercept right here is the y-intercept that's on the graph. That's on the graph. This m and n is the y-intercept from the equation. Okay? And then this constant right here is whatever multiplication adjustments that we have to make them equal to each other. Okay? Why did I put not 0? It's when x is equal to 0. It's because in order to find the y-intercept, x has to equal 0. Okay? When x equals 0. Okay? And then finally, step 5 is we deal with any holes. We deal with the holes. All right, so adjustments. We have two types of adjustments that we have to worry about. We have two types. Okay, one. If graph horizontal asymptote is 0 or a constant, and the equation is not, then we have to adjust exponents. So if you have an x squared, so if you have a term that's being squared, okay, if you have a term that's being squared, then maybe you have to change it to a power of 4 to get your, to make it work. Or if you have a term that is x to the power of 1, then maybe you have to change your exponent to x to the power of 3. Okay, so an odd exponent with an odd exponent, an even exponent with an even exponent. That's what I mean by adjusting the exponents. Ooh, I'm running out of room. I'll put the other adjustment down here. So here's the other adjustment. Here's the other adjustment. Okay. If graph horizontal is a constant and the equation is different constant, then we adjust the y-intercept, or we multiply by a new constant. Then adjust the y-intercept, which it may fix it, or we have to multiply by a new constant. Okay, so those are going to go hand in hand. Your horizontal asymptote is not that it's going to equal the y-intercept, But your horizontal asymptote and your y-intercept sort of go hand in hand with each other when you do your adjustments. Because if you play with the horizontal asymptote, if your horizontal asymptote is a constant, if you play with that constant, you're probably going to change the y-intercept. So they go hand in hand. So that's where you have to worry about. That's why I talked about this, looking at your y-intercept versus the horizontal asymptote, because it may fix the problem. Okay? But those are some of the adjustments that we have to look out for. Okay? So let's look at some examples on the back. Give you a second to write things down. Actually, you guys can pause the video at your own discretion. Okay. Nice equation right here. What's the x-intercept? That's right, that has an x-intercept of 2. This is a linear equation, so it's just y equals x minus 2. There's your equation, done. Notice this equation. Right, and there's no y-intercept here showing, so we're just going to worry about the x-intercept. All right, right here. Right, the x-intercept is 2, but what do we notice here? This is a bounce. Well, how do we identify a bounce? That's right, the term is being squared. It's the factored squared. So y equals x minus 2 squared. All right, and then here's that classic drag through. There's that classic drag through, so that's right, power of 3. So y equals x minus 3, x minus 2. Y equals x minus 2 to the power of 3. So there's that classic drag through. Okay. All right. Now here's a third degree equation. So y equals, and now notice, remember third degrees, they start low, they do their squiggles, and they finish high. So x minus 1 and x minus 2, minus 3 squared. Okay. All right. Look at this one. That's right. This is a third degree that's upside down. Third degrees start low, squiggles finish high. This one's upside down, so what does that mean? That's right, we have a negative in the front. So we have y equals negative parentheses. Let's see. I'm assuming this is a 1 and that's a 3. So we have x minus 1, x minus 3 squared. All right, there's your bounce still. Okay, here we have a y-intercept of 3/4, and we have a vertical asymptote. So this is going to be a rational equation. Does this cross the x-axis? Right, there is no x-intercept, but it has a vertical asymptote. But where do the vertical asymptotes go? They go on the bottom. So at best, we're going to put a 1 at the top. So y equals, we're going to put a 1 at the top, and we're going to put an x minus 2 at the bottom. All right, now here's something that's unique. Do you see this thing? It looks like a volcano. That indicates that there is no sign change. Okay? Think about this. If I am to the left of 2, we're supposed to have negative results, correct? But this fraction is saying positive. Okay, and then on the right-hand side, there was no sign change. So what exponent says no sign change? I'm not changing the signs, they're all positives. That's right, it's squared. So this quantity is being squared. Okay, so right now, we have our equation with no sign change. So it's all positives. So our graph is totally above the x-axis. All right, so now, but our y-intercept here is 3/4. Oh, horizontal asymptote. What's the horizontal asymptote? That's next, right. Horizontal asymptote is 0. What's our horizontal asymptote here? That's right, we have a constant on top over x squared, that's 0. So the horizontal asymptote is taken care of. Now we're worrying about the y-intercept. Well, what's the y-intercept here? If I plug in 0 there, that's right, this y-intercept here is 1/4. But that's not 1/4, that says 3/4. So that's when we have to do our little bit of adjustment. So we have our 3/4 is equal to some constant times 1/4. Okay? Remember, the y-intercept here is 1/4. Plug in 0. All right, so now I got to solve this. So what do I just, oh yeah, hopefully it'll just say, oh, I just got to multiply by 3. That's right. 4 times 3 is 12, and divided by 4 is 3. So k equals 3. So I just have to multiply this top by a 3. Yeah, you can say 3 times 1. All right, yeah, but it should be 3 over x minus 2 squared. There's our official equation, y equals. Okay. Oh, here's another fraction, right? So we're going to have a numerator and a denominator, right? The x-intercept here looks like it's 1, because that's 2, so that's 1. So what do we have here? Now I'll squeeze it in over here. Y equals. Okay, so our x-intercept is 1, that goes on top, so x minus 1's on top. Then we have a vertical asymptote, that's on the bottom. All right, what's our horizontal asymptote? Right, our horizontal asymptote here is 1. There it is right there, dotted line at 1. Does this right now have a horizontal asymptote of 1? Yes, it does. If I cover that up, x over x, it has a horizontal asymptote of 1. So that's checked, that's taken care of. Now we have to worry about the y-intercept. What's the y-intercept on the graph? 1/2. What's the y-intercept right here? What happens when you plug in 0? Right, plug in 0, I have -1 over -2, 1/2. Guess what? We're done. Taken care of. Okay. All right, new one. Here we go. Vertical asymptote, x-intercept. Start with our fraction. All right, what do we have here? So we have x minus 1 at the top. Ah, look at that volcano effect. That volcano effect is a square. Your exponent's going to be squared again. Because we've stopped and we start in the same location. That means no sign change. No sign change is when you have a quantity squared. Okay? We started and we stopped. We stopped and we started in the same spot. That means no sign change. Okay. So we have now what's our horizontal asymptote? So our horizontal asymptote is 0. What's the horizontal asymptote here? That's right, it's 0. X over x squared. The degree at the top is smaller than the bottom. Then that goes to 0. So we have horizontal asymptotes taken care of. All right, y-intercept. Well, this y-intercept is -1 over 8. What's the y-intercept here? So, you plug in your zeros. So I have a -1 over 4. That's right. Remember, you got to plug in zeros. Okay, that gives us -1 over 4. But that says -1 over 8. That's right, we have to do some multiplication. So -1 over 4 times some constant has to equal -1 over 8. Okay, and what is it? That's right, I hope you're saying 1/2 as you solve that algebra. Okay, I'll multiply by -4. So -4 over 1. So we get 1/2. Okay? Or cross multiply. And then divide by -1. Okay? But we get a half. So I have to multiply this fraction by a half. So I'll put the 1 at the top, 2 at the bottom. There you go. We're done. All right, do I have to put the 1 there? No, I could have just put a 2 at the bottom. But I showed multiplying by a half. Okay. All right, what's going on here now? Here's pretty wackiness. All right, so what do we have here? We have an intercept at 0, and we have a double intercept at 3. So your intercepts go at the top. So I have an x, and then I had times an x minus 3. And that minus 3 is squared. Very good. Okay. And then what's our, look at that, fraction bar. Y equals. Okay. And what's our vertical asymptote? Right, we have an x plus minus 2. Is it being squared? No. It finishes down below and it starts up top. There is a sign change, so that's it. That's a minimum degree of 1. That's a minimum degree of 1. All right, now what's our horizontal asymptote? Right, there is no horizontal asymptote. Look at this. This thing goes on up forever. This thing goes up forever. There has no horizontal asymptote. And there's no slant in here either. We don't see any dotted lines going obliquely, diagonally. So, this has no horizontal asymptote. So that literally means the degree at the top is more than the degree at the bottom. What's the degree at the top? Right, we have an x times x squared. We have an x cubed at the top, x at the bottom. This has no horizontal asymptote. Okay? All right, now we got to worry about the y-intercept. Well, isn't that the y-intercept right there at the origin 0? And what happens when you plug in 0 for everything? Guess what? We get 0. So, we're done. That's done. No more work to do there. All right, last one. A lot of stuff going on here. That's okay. I'm going to use this fraction bar as this line right here is my fraction bar. So y equals, here's my fraction bar. Intercepts, right? We got an x-intercept right here at the origin. So x, and isn't that a bounce? Yes, it is, so it's x squared. All right, vertical asymptotes. That's right, they go on the bottom, right? We have one at x plus 1, and we have one at x minus 1. Okay? Now, sign changes. Are there any sign changes on these? Right, no, this one finishes high, starts low. So that's just x to the power of 1, a minimum degree of 1. This one finishes low, starts high, so that's a minimum degree of 1. So we have an x squared over x squared. What's our horizontal asymptote here? 1. And what's the horizontal asymptote in the picture? I'm going to say it's 1. Okay? So horizontal asymptotes were taken care of. Now I worry about the y-intercept. Well, wait a minute now. What's the y-intercept? That's right, the y-intercept is 0. So what happens when we plug in zeros? We get 0. So horizontal asymptote's done, the y-intercept's done. Guess what? We are done. Okay. You'll see it in the homework.